Hey, good evening. This is Mr. Steele, and I'm here to help you with some of the Algebra 2 standards, in particular standards from terms 3 and 4. I'm going to start this video review series with standard number 3, which deals with complex numbers. So before we start on our first example of a problem that might turn up in your standard quiz, I want to start by reviewing a couple key facts here about complex numbers, which kind of help motivate what we're going to do. In particular, the first one is that I, the imaginary number itself, is equal to the square root of negative 1. Now it might seem kind of weird because of course the imaginary number I, which is the square root of negative 1, doesn't actually exist. Like you can't just measure I units. But in fact this is really helpful because if we can take the square root of negative numbers, we can actually solve lots of quadratic problems as well as other problems that we couldn't before. It basically allows or paves the way for the fundamental theorem of algebra. And the second is just kind of a corollary of that. And that is that if I is the square root of negative 1, that means that I squared equals negative 1. And so anytime we run into an I squared in our calculation, we can just go ahead and replace it or substitute in negative 1 and then simplify it from there. It works out really nicely. So with these two facts in the back of our head, basically we're going to start with the simplest kind of problem that we can be asked to do for complex numbers in this standard. And that is, of course, just adding or subtracting them. Or in this case, doing a little bit of both. When you're adding and subtracting, basically it comes down to one thing. You're going to combine like terms. Now there's some little catches and caveats in there, in particular those key facts over on the right side, but for the most part that's really all we're doing is we're combining like terms and using all the normal algebraic techniques that we know. So looking over here, I'm going to be computing 3 plus 5i minus 2 times the complex number 1 minus 7i. So to start, my first strategy is just going to be to get rid of all these parentheses by simplifying with what I have. So this first one, 3 plus 5i, it's just going to be 3 plus 5i. Nothing really fancy there because there's nothing being done to it on the outside. The second one, though, I've got minus 2 times this complex number. I'm going to distribute that negative 2, which I'll think of it as a negative 2, even though it's really subtract 2, into both of these pieces, giving me then negative 2 times positive 1 is negative 2, and negative 2 times negative 7i, which is plus 14i. And there we go. Notice the parentheses are no longer in the problem. We've got everything kind of on a level playing field. Once we're here, it basically comes down to time of just combining like terms. So we look for all the real numbers, for example. There's a real number. That's a terrible box. Let me fix that. I'll erase my little dot. So there's a real number. There's another real number. And of course 3 minus 2 is 1. For the second part, other like terms, I see plus 5i plus 14i. Again, forgive my poor attempts at circles. 5i plus 14i is going to be 19i. And in fact, this is our final answer. There's nothing to simplify. Sure, I is the square root of negative 1, but this is an accepted notation for a complex number. And so we have found the sum of those two complex numbers and done some operations in both ways. So if it's combining like terms that you're asked to do, shouldn't be too difficult to go through. So let's move on to something a little more challenging. Okay, so looking at something that's slightly harder than addition and subtraction would be multiplying actually complex numbers. That's when we'll start to get to use some of these key facts over here as we go through simplifying. Basically, the first thing you might notice when you look at this is this really just looks like binomial multiplication. Good old FOIL, and in fact, or the box, whichever way you want to go. And in fact, that's really what it comes down to doing, is it's just basically multiplying binomials. So I'll throw that off on the side. This is kind of our tip. Binomial multiplication. And as I said, I kind of threw those names out there, the buzzwords out for binomial multiplication. But there's a couple different ways. One way is FOIL. One way would be the box. There's lots of different ways that you can handle this, either way. And in fact, multiplication is really going to be an essential component when we actually go to dividing complex numbers. So what we're going to do is we're basically going to do just like we would in any other binomial multiplication case. We're going to FOIL or use the box, whichever way we want to multiply. In this case, I'm going to use FOIL just because it's a little easier to do with my little pen here. So let me change the color. Let's go to red. And now let's go ahead and start. So in fact, the first part, I'm going to multiply 4 times 5. 4 times 5 is 20. Next one would be 4 times negative 2i is negative 8i. So notice we've got an imaginary component in there too, which makes sense. When you multiply stuff with imaginary components, you should get something with some imaginaries most of the time. The next part, positive 3i times positive 5 is going to be plus 15i. And then last but not least, but certainly most imaginary, positive 3i times negative 2i is going to be negative 6, and then simply multiplied I times I squared. And so there it is. That's what came out of our foiling. 20 minus 8i plus 15i minus 6i squared. Now as you look at it, you probably see that there's two terms that have i's in them, as well as an I squared. So that is one component of what we're going to do. We might as well combine like terms, just like we did in the last one. So right back to CLT. Notice how these things kind of build on each other. So from here, negative 8i plus 15i is going to be just 7i. So we'll have 20 plus 7i minus 6i squared. But now here's that thing. We have 6i squared. Well, the thing about I squared is that we know what I squared is. I squared, right there, that guy, is negative 1. So in fact, we can just shove that right in there and substitute it. We'll have 20 plus 7i minus 6 times negative 1, because as it says over here, I squared is negative 1. So once we substitute this in there, we're actually going to end up with more like terms. Negative 6 times negative 1 is positive 6. So 20 plus 7i plus 6. And then, of course, what does that do? Well, we combine like terms again. 20 plus 6, 26 plus 7i. And there is the product of those two binomials. Well, they are binomials, but those two complex numbers. There we did. So first we used whatever binomial multiplication trick we liked. Then we combined like terms. Then we used one of those key facts. We used that I squared equals negative 1. And then once again we combine like terms. And you know what, I'm going to abbreviate it as CLT, because I'm getting tired of writing the word combine like terms. And so there we go. Multiplying actually comes down to a skill you've practiced a whole bunch of times, plus one other little fact that we know about complex numbers. Okay, 2 down, 1 to go. Okay, so moving on to the last little complex number skill you'll be asked to apply on the standard quiz. That would be, of course, dividing complex numbers. And so you'll have an expression that looks like this. It just looks like a stacked fraction full of imaginary and real components. So the question always comes up, well, what do I do? Well, in reality, what we're doing is we're rationalizing the denominator. Because, as it says over here, I equals the square root of negative 1, this means that we have a square root in the denominator. And even when that square root produces something that isn't real, we still have to get rid of it from the bottom in order to satisfy mathematicians' sense of taste. Let's put it that way. Let's put it nicely that way. So the trick here is a little bit different. This is something that's a little bit weird. What we're going to do is we're going to multiply up and down, just like we would if we were rationalizing. Multiply up and down by something called the complex conjugate. So complex conjugate. And now the complex conjugate is a little weird, so I'll switch to a different color pen really quickly so that we can kind of set this aside from our work. And the complex conjugate basically says that if I'm looking at the complex number a plus bi, then a plus bi has the conjugate, or the complex conjugate, that's really what it is, a minus bi. Basically it's the same real part. Notice the real part stays the same, it's still a in both cases, but then the imaginary part changes signs. Instead of plus bi, the conjugate is minus bi. And now the real motivation for doing this is that when we do this down here and multiply by the conjugate of the denominator, it's going to actually create a difference of squares that will allow us to simplify. So I should add that to my little strategy right there. So complex conjugate of the denominator, or the bottom of our little complex number-filled fraction. Denominator. Harder to spell than I thought. Okay, so what does that look like? Well, let's do this. Let's change colors again, because I like pretty colors. Pen settings. Let's go through and actually show what that looks like. So, first thing I'm going to do is I'm going to add some parentheses here, just because I got to remember that I'm going to eventually end up multiplying. And when you multiply, it's just like binomials. You have to FOIL and do all that stuff. So I'm going to multiply these complex numbers by the conjugate of the denominator. So my denominator is 1 plus 5i, so the conjugate is going to be 1 minus 5i. So I'll just point out that that's the conjugate. It's the conjugate of the bottom. And of course, if I multiply by that on the top, or on the bottom, I need to do it on the top as well. So up and down by that guy. Of course, the reason is that means we're just multiplying by 1, which is totally okay. Multiplying by 1 means nothing changes. We're just going to change the form. And so now, of course, what do we got to do? Well, from there, we just binomial multiply, just like we did in the last one. Difference is we're going to have to do this a whole bunch of times. Or, well, not a whole bunch, we're going to have to do it twice. So we have to be a little careful. So in this case, I'm going to start with the denominator. It's probably a good place to start, just because stuff might simplify. So down here, if I multiply it out, there's a shortcut, but for now, let's pretend you don't remember the shortcut. 1 times 1 is 1. So that's that one. 1 times negative 5i is negative 5i. Then plus 5i times 1 is plus 5i. And then the last one is plus 5i times negative 5i is negative 25i squared. Now what I would hope that you notice here, as we're looking at the bottom, is that this middle term with the single little I, gonzo, it just goes to 0. They cancel out. In fact, it's because it's a difference of squares. So all we're left with is 1 minus 25i squared. Well, 1 minus 25i squared, 25i squared, this guy is just negative 1. So in fact, the bottom is actually 1 minus 25 times negative 1, or 1 plus 25. And of course, 1 plus 25 is 26. So our denominator of this guy is going to end up being 26. So whatever we end up with, it's going to be over 26. We might have to simplify from there, but at least we've got that. So the bottom is good. And it came out to be a whole number, because even though I didn't make a big deal about this, remember our goal was to rationalize the denominator and get rid of this I, which is square root of negative 1. Done. Got 26 sitting down there. Okay, so now the top part, we'll do the same thing. We're going to have to multiply it out. So first, 3 times 1 is 3. 3 times negative 5i is negative 15i. Wouldn't expect anything to cancel here. It's not so convenient. Positive 2i times 1 is plus 2i. Nothing canceled. That's okay. And then plus 2i times negative 5i is going to be negative 10i squared. So a couple things to do here. We're going to have to combine like terms in the middle, and then we'll have to simplify that piece. So first, combine like terms. Negative 13i, so 3 plus negative 13i. Now over here we know that I squared is negative 1, so negative 10 times negative 1 is going to be plus 10. So from here, combining like terms again, we'll get 13. Yeah, it was 13, wasn't it? Weird. I didn't expect this. That's what happens when you don't do all the problems before you start ranking the videos. So we'll get 13 minus 13i, and so that goes right on top. And it would appear we have our final answer. But there's a problem. Not really a problem, there's just something else to do. Notice that in our answer here, we have 13, 13, and 26. Problem is they all have a GCF. 13 goes into all of those guys. So what you can imagine we're doing here is we can then just simplify it like we would any other fraction. So 13, 13, 26, their GCF is 13. So imagine that you're pulling out a GCF of 13. That'll leave you with 1 minus I on top. On the bottom will be 13 times 2. We're just simplifying here. The 13's go away. We get to our final answer. 1 minus I, or 1 minus 1i, all over 2. And of course we could separate it into two numbers like 1/2 minus I over 2, or minus 1/2 I. Don't have to, that's as good as we want. And so there we go, we've kind of hit everything for complex numbers in standard number 3. We started by talking about the key facts themselves about complex numbers, and how to simplify when you're just adding and subtracting, which amounts to combining like terms. Then for multiplying, we learned that it just comes down to multiplying things out using FOIL or the box, whichever your favorite is, and then simplifying when you recognize that fact of I squared being negative 1. And then finally, we actually divided complex numbers by multiplying by this thing called the complex conjugate, which just switches the imaginary part's sign up and down, applying the FOIL or the multiplying part a couple times, and then simplifying if we need to. And there you go. That is standard number 3 on the standard quiz in Algebra 2. Hopefully this video has been helpful to you. This is Mr. Mike J. Steele signing off. Have a good night.